All right, so let's look at some basic exponential functions. So in A, I've got an example of exponential growth. I'm always going to start with my y-intercept. So my y-intercept is 0, 1. The next point I'm going to look at, I'm going to think about 3 to the power 1. Of course, that's 3. 3 squared is 9. 3 cubed is 27. And this is why I call it exponential growth. It's growing really quickly. 3 to the power negative 1 is 1/3. So already I'm close to my x-axis, 1/9, 1/27. Too small for me to graph, so I'm just gonna get close. And then I'm gonna shoot on up. And then I'm gonna include my asymptote as well. So I'll label that y equals 0. And I'm gonna have the same thing over here, so I'm gonna come in and add that as well. And then, of course, I'll label this as well. Y equals 3 to the x. On this side, I have a half to the x. Again, I have 0, 1. If x is 1, I'm going to have a half. If x is 2, I've got a fourth. So already getting really small. If x is negative 1, 1/2 to the negative 1 is the same as 2 to the first power, so that's 2. Negative 2 is going to give me 4. Negative 3 will give me 8. And negative 4 is going to give me 16. So I can see that this one, the change is not as dramatic as when the base was 3. So thinking about this, I could say that this is the same as 2 to the negative 1 to the power x, which is the same as 2 to the negative x. So I could think of this as a reflection of the 2 to the x graph over the y-axis, because there's my reflection with my negative x. So normally I would look like this, and now we've reflected it across the y-axis. So let's look at matching some equations with graphs. So 1/5 to the x and 1/2 to the x, this is decay. This one's also decay. And if I think about, decay, if I think about what's happening, this one is decaying more rapidly than this one. I know if I have negative 1 as my x value, I'm going to have 2. Over here, negative 1 as the x value will give me a y value of 5. So negative 1, 2, negative 1, 5. A must match with 1/5 to the x. This one that's decreasing less rapidly, so this one decreases much more rapidly. This one must be 1/2 to the x. Similarly, in these growth functions, this one is going to grow more rapidly than this one. So C must be my 8 to the x, and B must be 4 to the x. I can check that with 1. I see I've got the point 1, 4, and at 8, I've got the point, at 1 I have the y value of 8, so that matches with my 8 to the x, matches with my 4 to the x. All right. I'm going to come back in the next video and we'll talk about reflections and shifts, etc.